today I wanted to go over a few of these examples. I'm going to pick just a handful of these to kind of work through, and what we're going to do, so I'm going to do a few and I'm going to allow you to continue to practice and work on these for just to get better at doing problems like this. So I'm going to pick a few of these to do, maybe 2 or 3 of them, one of each type, and then I'm going to let you keep working on these. If you have questions, make sure to send me a message or get with someone who you knew that does understand this kind of stuff. And so just ask, and our goal is to make sure we can understand the steps necessary to complete all of these things. Okay, so number 1, we're looking at the cosine of theta, and it tells me I have a negative 3 pi over 4. Now, I'm not really concerned about what the actual angle is. If I turn that into degrees, I know that would be negative 135 degrees. What's really important is what you see right there, right? This fourth, what that tells me is if I were to draw this vertical line and try to create this little angle, well, I know this is negative 180 if I keep the whole negative idea going. And that tells me that when I come in, I know that this angle, the reference angle, would be pi over 4, or just 45 degrees. Now, why is that important? Well, because that tells you that when you go to work this out, the parts, the sides, I'm going to go back here and I'm going to say this is 1, 1, and square root of 2. However, we realize we are in the third quadrant. When you get outside the first quadrant, you've got to remember that your signs of your side lengths are going to change. In the second quadrant, it's going to be the x negative. In the third quadrant, they're both negative. And over here in the fourth, your y value is negative. So I'm going to go ahead and add these negative values in. We know that cosine of any angle is going to be the adjacent over the hypotenuse, and that's no different here. And so I'm going to go in here, and I'm going to write down that value, which is going to be negative 1 over the square root of 2. But we've seen this enough times to know that rationalizes to negative square root of 2 over 2. And that's how that works. Now, another way to do this is to consider taking my angle measure. Now, I can keep it in radians if I needed to, negative 3 pi over 4. But I think most of you really enjoy going back into degrees because it's just more comfortable. I'm going to find a coterminal angle by adding that 360 degree. Okay, if I add that, it ends up getting 225 degrees. Now, how does this apply to the unit circle? Well, if you look on your unit circle, so take a second, grab your unit circle, or open up another tab somewhere so that you can kind of look along. I know that if I write down this angle, 225 degrees, and if you look in your third quadrant, you know that the unit circle has certain coordinates. Those coordinates would be square root of 2 over 2, negative square root of 2 over 2 for x, and then negative square root of 2 over 2 for y as well. What I realized is that the cosine of the angle is the x part, right? That's the x part. And the sine of the angle is the y part. And we have both of those. So I could have been asked for the sine or the cosine. I have both those things right at my hands. And so I can look at my unit circle. I can find the angle I'm looking for. And if I've been asked for one of these trig functions, I can simply remember which is which. This is kind of nice because they're both the same. But I could look at the coordinate and I can get it from there. That's 2 ways to do these questions. These particular questions have been designed so that you are working from angles that are very, very similar to the unit circle ones. So I'm going to leave the rest of them for you to do. You're welcome to convert to degrees. You are also welcome to take the angles that are negative, add that 360 or 2 pi if it's radians, and work at it from an angle that is present on the unit circle. Okay, let's keep going. Let's do one that is radians, is negative, and there's no picture. So let's do probably the one that you probably don't want to do is number 5. For me, I'm very visual, so I'm going to go ahead and I'm going to draw what this looks like because it helps me to get my mind around what it is I'm doing. It helps me make decisions that are clear and I'm not confused about what I'm looking at, right? So we start our angle there. 5 pi over 4, if you convert that in, that's negative 225 degrees, right? So I'm going to go, obviously that's 180, so I've got to go past the 180 and up into the third quadrant. If you think about it, this would be negative 270, and this one is negative 180. So we know that we're in between those values. Not a big deal where you put that mark. We just know the angle's up there. Now, I'm kind of cheating because the last one we did also was a 225 degree angle. But let's suppose it's not. We didn't realize that. So I could add that 360 degree value just to get it back into the positive range between 0 and 360. I know that's going to end up giving 135 degrees. Now, you probably had a feeling that that was going to happen if you're looking at your unit circle and thinking, well, hey, the 45 degree angle up in that quadrant is 135. And you would be exactly right. And that's very good if you thought that or kind of caught that suggestion well ahead of what I mentioned it. So 135 degrees would be here. Okay. Here again, I can go ahead and label 1 because we know this is a 45. And this would be square root of 2. I'm going to go ahead and add the negative in because we are in the second quadrant and the x-coordinate, the horizontal piece, is negative. For tangent and cotangent, I really do like looking at the triangle. There's a way to do it with the unit circle as well, and I'll show you how to do that in just a second. I'm going to go ahead and write down the adjacent over the opposite. Tangent and cotangent with the 45, it's always going to be 1 or negative 1. So here we know that we're in the second quadrant, so we're going to have an adjacent side of negative 1 over positive 1, which is just negative 1. If I write the coordinates down for 135 degrees, so let's come up over here. We know that if we look up there, it's going to be negative square root of 2 over 2 and square root of 2 over 2. We know the x and the y happens to be like this. We also know that when we work this out, I told you in class that tangent of whatever angle we're working at was also the y divided by the x inside the unit circle, so that we can imply the cotangent would be the x over the y. So if we do that, we're going to get negative square root of 2 over 2 divided by the square root of 2 over 2. I told you also that the bottom 2's cancel, but if we look at it really close, we know that it's the same thing on the top and bottom, which is going to give us just that negative 1 value that we already knew was going to show up. It's two ways to look at it. My first gut thought is to use the unit circle, but I also really like to use our right triangle process too. This process will hold true for every single possible triangle we could ever create. The unit circle one is very useful, but it is very limited to the angles that you find on the unit circle. If we get outside of that, some of those rules don't apply. Okay, so when you're working on some of these other ones like 6, 7, 8, go ahead. If you want to convert to degrees, perfectly fine. Draw the triangle or find that degree measure, that angle measure on the unit circle, and see if you can work out the secant, the cosine, or even the tangent of that by using the coordinates. In number 9 and 10, we've done this a number of times, but just to kind of take a good review. Let's do number 10. I'll let you do number 7, or number 9, excuse me. If I draw this out, we know that we are in, this is your x and your y coordinates. We're going to go negative, negative, so that means I'm in the third quadrant, so negative 1, 2. The square root of 5 is not a very nice whole number, but I'm not really concerned about getting the picture drawn very well, right? Because I've got the sides labeled. And so x is going to be negative 2, y is going to be negative square root of 5. What I need to know for secant is the hypotenuse divided by the adjacent. Well, I don't have the hypotenuse, but I know a very good way to find it. Negative 2 squared plus negative square root of 5 squared, and that would be equal to your hypotenuse squared. So this is going to be 4 plus, let's see, that's going to be 5. So we're going to get the square root of 9, which is 3. So positive 3 there. I want to make sure that I have a number that's definitely larger than the other two, and you'll find out that the square root of 5 and 2 are both less than 3. So I'm going to write this down now. So we have the hypotenuse of 3 divided by negative root 5. Now, of course, if I had the answer key, I wouldn't see that. So let's go ahead and rationalize just for practice. And so we're going to have square root of 5, and then we're going to end up getting 3 square roots of 5 divided by 5, and it's of course just negative. And so this is probably the answer you're going to see, but I would also be okay with you writing this as answer 2. There are a few of those, right? And you can take these and practice them. I did one of each type. Hopefully you have been used to seeing this, and it's going to be something you can work on. If you get questions, make sure you please email me.